If you don't remember the equation for the slope of a line, go back to page D in your journal and write this down. Slope is equal to y2 minus y1 over x2 minus x1. That means that you're finding 2 points along a line to find the slope. Now our first point is going to be easy because our first point is going to be 0, 0. Now I need to find a second point somewhere along this line. I'm going to ignore everything that I have drawn on this page so far except for this best fit line. I don't care about any of these dots or either of these other 2 lines I drew. I only care about this green best fit line. And what I'm going to do is I'm going to start all the way in the top right corner and I'm going to move backwards along this line. And I'm going to look for a place where this line crosses over an intersection of these blue markings on my graph paper. The reason for that is because I know exactly what the value is of each one of those blue lines. And I want to be as close to reality as possible on my slope. So I've lucked out because I found a spot right here at the very end of my line. My x value is 100, my y value is 68. I could go along and I could try and find another spot on the line if I wanted to, but that's a pretty good number. I'm going to use that. So I'm going to circle it and I'm going to write down my coordinates, x, y. So my x is 100 centimeters squared because we have units, and my y value is 68 grams. So this is our point number 2, this is our point number 1. Now I'm going to just plug in my numbers. Y2, 68 grams, minus y1, which is 0, over x2, which is 100 centimeters squared, minus x1, which is 0. So 68 grams over 100 centimeters squared. Now in physics, you will never ever leave a number looking like this. Always finish out your division and write it as a decimal. So hopefully you don't need a calculator to do this, but just in case. And your number won't be this equal, so go ahead and grab your calculator and do your y values, your 68, divided by the x. And this is the slope of my line. So the slope of my line is equal to 0.68 grams per square centimeter. We didn't cancel any of our units here. We still have units. So our slope, 0.68 grams per centimeter squared. Now, we're not finished yet because ultimately what we're looking for is the mass of a full floor tile. We know the area. The area of a full floor tile is 930 square centimeters. And now we know the slope of a line. So what can we do here? Well, look at our equation for a slope. Y over x. Our y is a mass. Our x is an area. So the slope of this line is mass divided by area. If I know the slope and I know the area, I can rearrange this equation to find mass. And that tells me that mass is equal to slope times area. Now I can take this slope that I've calculated and I'm going to write over here. Notice I'm putting all my calculations right here on my graph. I'm going to say that my mass is equal to my slope, 0.68 grams per square centimeter, times I'm writing it underneath because I ran out of room. My area, which is 930 square centimeters. And when I multiply these, my units for area are actually going to cancel. And so I take my slope, which is still on my calculator, times the area, and I get 632.4. Here's where we go back to our significant figures. If you look at your measurements for mass, that gave you 4 significant figures because that's exactly what the electronic balance told you. Your area should only have 3 significant figures because that's the most that you can get out of any one measurement, 3 significant figures. So we're going to keep this to 3 significant figures as well. So our mass is equal to 632 grams. That's going to be our final answer for the mass of a full floor tile based on the data that we collected. Now there's one more piece that we need to do. I want to know how far away is this answer from reality. Remember percent difference from yesterday? We're going to do that now. So percent difference is equal to actual minus experimental, which I'm going to just abbreviate EXP, divided by actual, and then times 100. I can tell you now that the actual mass of a floor tile is 641 grams. So my actual minus experimental, 632 grams, divided by the actual again, times 100. Now when we plug this into a calculator, I want to make especially sure that my calculator knows what it is I'm trying to say. So I'm going to hit equals after each part. So 641 minus 632, and I'm going to hit equals. Then divided by 641 and equals again. Now times 100. So my percent difference, and all of these grams now cancel out. So my percent difference is 1.40. I'm going to keep that 0 because I need 3 significant figures in my final answer. And it's a percent, so 1.40%. This tells me that I'm 1% off of reality in my calculation here, which is really, really good. Now we're finished with the calculations. What I want you to do with your graph now is to attach it onto page 2 in your journal. So you turn it sideways. You can put your glue or your tape along the long edge or the short edge. If you don't have any calculations or anything written on page 2, you can just glue it flat if you prefer that. If you have some things written on page 2, make sure that you can sort of fold it up and out of the way.